We have a function g of x, which whatever you give it takes that number, subtracts 3, squares it, and then adds 1. We have this interesting restriction. This is called a domain restriction over here. It means you can only put in numbers that are bigger than or equal to 3. As far as our work goes for finding the inverse, we can ignore that little rule with the comma on it. When it comes to our check, we'll have to respect it and keep it in mind. But for now, what I know is I'm going to replace this with a y, and then I'm going to interchange x and y. So instead of saying y equals, root x with this stuff, I'll say x equals y minus 3 squared plus 1. And now we'll go to the business of solving for y. This is the kind of thing that intimidates you. I want you to keep in mind this little PEMDAS that we always use for everything since like 7th grade. I do want to add a little something to it though. Next to exponents, the opposite of an exponent is a radical or a root or a rational exponent. Those are all kind of ways of saying the same thing. But addition has its subtraction to undo each other. Multiplication has its division to undo each other. And exponents have roots or radicals or rational exponents depending on what's going on. So we are going to focus on getting this y to be all by himself. It is totally trapped inside of these parentheses. So everything inside of here I don't care about. I'm just going to look outside of these parentheses, start way down at the bottom here, and say, outside of those parentheses, is there anything that needs to be added or subtracted? And I can see there's a plus 1 here, so I'm going to go ahead and subtract that 1 from both sides, making the left side x minus 1 since I cannot combine those terms. And the right side is going to become parentheses y minus 3 squared, and of course that positive 1 canceled. I will look outside the parentheses and see if there's anything to multiply or divide, but outside the parentheses there is not. That's done. Outside the parentheses, are there any exponents? There is. And the way we get rid of an exponent is with the corresponding root. So if it's a squared exponent, we're going to use the square root. I don't need to write the little 2 over here because that's implied. So I'll do that to both sides, and it goes to the entire side. The whole side gets square rooted. So you don't do each part individually, it just goes over the entire left side, making the left side the square root of the quantity x minus 1 equals, and of course this square and square root are going to cancel, leaving y minus 3. Then I'm going to look at this right side and say, is that y by itself? It's not. We have gotten rid of the parentheses, so I'm back down at the bottom, and I'm saying, is there anything to add or subtract? I'm going to add a 3 to both sides. When you add the 3, it can't creep its way into this radical. It's got to stay outside. So the final answer is going to look like the square root of x minus 1, the positive 3 on the outside, equals y. And for a final step, I do want to express or communicate the idea that this expression undoes what this expression did. This expression was called g, so I'm going to call this one the inverse of g. So again, we're using that exponential equation, but that's not really an exponent at all. It just means g inverse equals root x minus 1 plus 3. Now for my mental check, this is my brain. I'm going to pick some random number that respects this condition. So maybe I'll pick a 7. Sure, let's do 7. That's a good one. If I take 7 and I plug it into g, whatever I plug into g, it's going to take that and subtract 3. So 7 minus 3 is 4. We're going to square that. 4 squared is 16. Add 1 to get 17. So plugging 7 into g gives us 17. We'll now go over the inverse function with that 17, and we should get that 7 back. So if I take 17 and plug it into inverse, the inverse takes the number, subtracts 1, so 17 minus 1 is 16. Square root of 16 is 4, and then I'm going to add 3. 4 plus 3 is 7. So this does what it's supposed to do. The function g turns 7 into 17. The inverse turns 17 back into 7. It's not really a complete proof, but it's just a nice little verification for me. And you can usually do it quicker than I'm demonstrating. I'm trying to pause, see if you guys have time to do the math in your head yourself. So it's worth the effort, and I hope you guys do it. Good luck.